on the second week of the semester, Dr. Rasul gave us a special project. It is material engineering subject, and the project of course relate to material. We have 8 weeks to get the project done. We are group 3. Yes, that's it, group 3. Our group 3 is assigned on biomaterial, so we meet to discuss the project. We have to deeply analyze on the material for us, biomaterial. So we did a meeting.
So everyone, today we are going to discuss about biomaterial. Does anybody know what biomaterial is? No? Okay, biomaterial. Biomaterial is a material that is natural or artificial that involves a whole or part of a living structure or biomedical device that performs, improve a natural function in the body or completely replace it. So does anybody knows what biomaterial consists of? Alloy, ceramic, metal, polymer,
Composite.
Okay, under ceramics, there is inert ceramic and consists of 3 types of material, which is alumina, carbon and zirconia. So can you guys find something about zirconia so we can discuss further about it? Yes, you? Do you find something? I can see from your face.
Okay, here what it is. Under ceramic zirconia, right? Okay, under zirconia there is zirconia dental implant. What it did is it has a good biocompatibility. It has a tooth-like color and it has strength.
That is why it's suitable to use in dental
Yes.
implant. Yes, okay.
As far as I know, in zirconia it has material named Y-TZP, which is bacteria tetragonal zirconia polycrystal.
Okay, I want to add something. Okay, the Y-TZP contain of 3 mol of Y-TZP and stabilizer also.
So we have discussed, and the material that we use is Y-TZP. Thank you. So after this, we will discuss more about Y-TZP.
Siapa sih?
Ceramic dental implant are divided into 2 categories, which are inert ceramic and bioactive ceramic. Inert ceramic consists of alumina, carbon and zirconia, while the bioactive ceramic consists of bioactive glasses and calcium phosphate. The biomaterial that we choose is ceramic zirconia Y-TZP. This material contains of 3 mol percentage of Y-TZP as stabilizer. Zirconia is a polymorphic material that can express more than one crystal line structure. It consists of fine grain structure that usually 98% tetragonal. Stress-induced transformation toughening is a unique characteristic of Y-TZP ceramic. Ceramic zirconia Y-TZP is the most suitable dental implant material because it tooth-like color, mechanical properties and biocompatibility.
Next, we will discuss about behavior of Y-TZP. The behavior of Y-TZP is metastable material with high crystalline content, and it mainly consists of zirconia, and it has 3% to 8% mole of Y-TZP, which is Y2O3, stabilized as a stabilizer, which stabilizes zirconia in its tetragonal phase. The transformation of toughening mechanism, which involves transformation from T phase to M phase. It does increase material toughness and also fatigue threshold. The M phase is known as monoclinic phase, which exists at room temperature, while the T phase known as tetragonal phase, which exists at 1200 degrees Celsius. The transformation from T phase to M phase occurs from one crystalline state to another during firing.
So, advantage of Y-TZP. First, no allergic reaction. In compare to traditional dental implant using titanium, some people do have allergic to titanium and they cannot wear it. Example issue is towards the hypersensitivity in allergic patient. For Y-TZP zirconia, the implant is inert, non-corrosive and hypoallergenic. Second, the good biocompatibility of the material. Y-TZP dental implant is one-piece design, so it lowered the degree of penetration by the bacteria in time where it is in your mouth. There are also no encapsulation and inflammatory reaction observed, stated by Hisburgus in 2009. Third and the last, Y-TZP has high strength and high wear resistance. It offers high degree of scratching, corrosion and fracture. Y-TZP has bending strength up to 700 MPa and has passed clinical chewing tests. In contrast, the disadvantage of this material is 1. Implant mobility. I quote, Donatella Duratio in 2015 stated that Y-TZP has 98% success while the 2% failure are affected from the implant mobility. Second, aging process. Due to low temperature degradation (LTD) of Y-TZP in the presence of saliva in the mouth, Y-TZP dental implant will undergo aging process that resulting to first surface degradation, micro cracking and strength degradation, and of course it is affected on the long run.
Recent scientific work that we find out is the researchers is questioning about the long-term stability of the material used, which is Y-TZP. Because of low temperature degradation of zirconia, or known as aging process, this process bring effect including surface degradation with grain pull out, micro cracking and strength degradation. So to control the aging phenomenon, several factors can be considering, which we found from the obvious use of stabilizer to the modulation of residual stress, such as the adjusting crystal size and removing impurities during manufacturing. Other than that, a research is conducted to improve oxide-based materials such as alumina zirconia composite, along with non-oxidic ceramics such as silicon nitride. Recently, a research was about to introduce small amount of alumina to Y-TZP, and the result is producing a material ceramic blocks known as TZPA, and the added traces of alumina upgrade the durability and stability under high temperature and humid environments.
So to conclude, zirconia ceramics have been widely used and well received in medicine, particularly implant dentistry, especially for abutments and full contour crowns. There are, however, a few things that needs to be looked into and studied further to avoid any consequences in the future. This includes the structures that are produced for ceramics are more fragile
and susceptible to crack propagation, so the presence of flaws, pores, and their distribution is what is often a limiting factor for strength and durability. Even though zirconia may have the potential to be a successful implant material, although this is not yet fully supported by existing investigations, and it needs further good quality research. Thank you.